Started.
Next slide. So, good morning to everyone. Yes, good morning. So we will wait for another 1 or 2 minutes. Okay, good morning. Good morning, doctor. So Manasa, Nagarjun, Harini, Manjushri, Snehashri, Manjunath, Meghana, that's what names I can say. But still, good morning to everyone. Okay, so what I will do is, before starting with the today's concept, as usual, I will brief about whatever we have done in the previous class. Fine? So, hagadre, what we had done in previous class, anyone? What we have discussed? We have discussed about amino acids, right? So we have discussed about amino acid. Very good, Janavi. That's where we have discussed about deuterionic structure. Very important. This is very important from your examination point of view. Then we have discussed about essential and non-essential amino acid, right? So that is also important. I will not make it as a very and all. So it is important, but deuterionic structure is very important, right? So that's what we had discussed in the last class. All of you have understood? Any doubts with respect to last class? Otherwise, we'll move to the next part. Fine? Okay? So in that case, we'll move to the next part. So that will be with respect to proteins. We'll move to the next part, that will be with respect to proteins. Now, when I am talking about proteins, as we have discussed or as I have told, proteins are those macromolecules which are having amino acids as their building block molecule. Or you can tell that proteins are those macromolecules which on hydrolysis will give n number or many number of amino acids. Right? So proteins are those biomolecules which on hydrolysis can produce or can release many amino acids. That's where we have the proteins. All of you will agree? So in that case, so now I will coming to today's concept. So in that case, we have to discuss about peptide bond. We have to discuss about the peptide bond. Now when I am talking about peptide bond, for example, I have an amino acid. This is COO minus. I have an amino acid. I will consider this one as 1, so I will have written it as R1 to indicate that this is first amino acid. Now it's going to react with another amino acid. It's going to react with another amino acid. So during that time, there will be liberation of water. That means 2 hydrogen atom will be taken and 1 oxygen will be taken. So what is left over? So left over will be R1 CO NH CH R2 COO minus. So that's what. So please remember, carboxylate can be written like this, right? Same thing we can write like this also, right? Now in the same way, this molecule as usual. So H2O, this one and this one. Here one hydrogen will be left over, and here oxygen will be, carbonyl group will be left over, right? So now that's where we have the peptide bond. This is nothing but peptide bond. Okay? So chemically, peptide bond is nothing but amide bond or amide linkage. Peptide bond is chemically amide linkage. CONH. That is nothing but amide. Right? But this amide linkage, if they are present between the amino acid, then they are called as peptide bond. Amide bond is a broad term. Wherever we will find CONH linkage, it will be an amide linkage, but it is not a peptide linkage. So peptide linkage or peptide bond is applicable only when amide bonds are present between two amino acids. So that's where now I can define. So peptide bonds are those amide bonds. Peptide bonds are those amide bonds which are present between the amino acid. Which are present between the amino acid in a dipeptide or a polypeptide, whatever it is. Okay? As a single amino acid, it cannot have the peptide bond, right? So when we have more than one amino acid, then only we can have the peptide bond. That's very important, right? So if you go back, there was a glycosidic linkage. We have discussed, right? Alpha and beta. Now can any one of you tell me, when I am talking about glycosidic linkage, chemically this linkage can be called as anyone? So glycosidic because they are present between two sugars. But chemically it can be called as which type of covalent bond? Glycosidic linkage. Anyone? Already I have told. So which type of bond it will be called as? Or linkage. I am talking about glycosidic linkage. Now here peptide linkage can be called as amide bond. Same way I told glycosidic linkage is an anyone? I will give a hint. There will be presence of oxygen. Very good. So Mayank has given the answer, that is ether linkage. Glycosidic linkage is nothing but an ether linkage. But wherever we have ether, we cannot call that one as a glycosidic bond. So it is applicable only when it is present between the sugars. Yes, you are also right. So that's where we have the ether linkage. So that is glycosidic bond. Here it is amide bond which is present between two amino acids. Then it will be called as peptide bond. All of you have understood? Any doubts? So that's where whenever we have the amino acids linked, there will be two terminal, amino terminal and carboxy terminal. That one you should keep it in your mind. Whenever we are talking about polypeptide chain. So what are polypeptides? Polypeptides are those biomolecules which can on hydrolysis will release n number of amino acid. Same as that of the polysaccharides. Right? So it will have two terminal, amino terminal and carboxy terminal. Right? Now peptide bond definition is done. Now very important point here is how many amino acids are present here in this chain. How many amino acids are present? Anyone? Here two amino acids are there, right? So therefore this molecule can be called as dipeptide. Based on this you can expect the question. So this is called as dipeptide. Two amino acids linked by one peptide bond. Then they are called as dipeptide. Please remember, many students they will get confused. They think that Dipeptide means two peptide linkage should be there. No. This number di stands for amino acid. Okay? So two amino acids linked by one peptide chain. Now in that case, I have amino acid 1, amino acid 2, amino acid 3, amino acid 4. Can you tell me, in the same as dipeptide, what can be this called as? Whatever I have written, this can be called as what? Same as that of the dipeptide, which we have discussed just now. Anyone? Anyone? Whatever I have written, it's very clear. 1, 2, 3, 4. 4 amino acids are there. So this molecule can be called as, same as that of the dipeptide I am talking about. Right? Okay. So this molecule will be called as, very good, Jannavi. Yes, this molecule will be called as tetrapeptide. Right? Tetra means 4. That 4 stands for 4 amino acids, not for the peptide linkage. So when I am talking about tetrapeptide, so this is a biomolecule where 4 amino acids are linked by 3 peptide bonds. So right? So that's where we have the tetrapeptide. Same way, if I will give pentapeptide, that means I am talking about 5 amino acids. Penta stands for 5, not butane. Butane and all is applicable for hydrocarbons, not here. Okay, na? It's not applicable here. So now pentapeptide, penta stands for 5. That means 5 amino acids linked by 4 peptide bonds. So what I mean to tell here is correct, Amit. It is 5. So what I mean to tell here is, whatever name is given, that will be amino acid, number of amino acid, and amount of number of peptide bond will be -1. That one you should keep it in your mind. It may help for your competitive exams. Fine? So that is related to peptide bonds. Any doubts? So that's where we have discussed about 2 important linkage. One is glycosidic linkage, that was with respect to carbohydrate, and now here we have discussed about peptide linkage, that is with respect to polypeptide or proteins. Fine? So shall we move to the next one? Okay? So in that way, now I will come to proteins. Now I will come to proteins. Right? So all these days, means yesterday and all, we have discussed about amino acid, component of the protein. Now we are going to discuss about proteins. Now when I am talking about proteins, as we have discussed, proteins are having building blocks of amino acid, or proteins will have building blocks as amino acid. In that way, if that is the scenario, I have polypeptide as one term, then I have protein as another term. Right? That's where I have polypeptide and a protein. They are not same actually. Now one thing I will make it clear. Yes, all the proteins will be made up of polypeptide. No doubt. All the proteins will be made up of polypeptide. But all the polypeptide may not be a protein. Right? So that's where we have the difference. Now what is that difference between a protein and a polypeptide? Then you should understand there is different levels of organization in a protein. See, for example, when I am talking about a house or bungalow, if you observe, first thing, what they will do when you are constructing a house or a building, what you are going to do? First you will lay the foundation. Right? So then it is not a house, it is only foundation. Then once foundation is done, then next level of organization, that is, you are going to construct the walls based on the design. Right? You are going to construct the wall. Another level of organization. right? So once wall is ready, so surround wall is ready, even you will construct in between with respect to the rooms, many walls will be constructed. Another level of organization is ready. Then at the end you are going to put the slab. That is final one. Now until unless you are putting the slab, you cannot call that building as a house. So once foundation, walls and slab, everything is there, then we can consider that one as a house. Got my point? So that's where I am talking about different levels of organization. Right? So now in case of the proteins, that's where we have the different levels of organization which is not found in a polypeptide chain. Which is not found in a polypeptide chain. Protein will have that different levels of organization. Fine? Hagadre, what is that different levels of organization? I am coming to a bit important point. Different levels of organization. That means first one will be primary structure. First one will be primary structure. You can write it as like this or word as primary. No problem. So now when I am talking about primary structure, it is nothing but amino acids. It is nothing but amino acids linked by peptide bonds. It is nothing but a sequence of amino acids linked by peptide bond. That is nothing but primary structure. Whether I am clear? So what do you mean by primary structure? These are the sequence of amino acid linked by the peptide bonds. But please remember, each protein, they have their own specific sequence. Pattern will be different for each protein. It cannot be same. If the sequence is same, then protein should be same. Got my point? I am making it very clear. Each protein, they have their own specific amino acid sequence. There is no question of same sequence in two different proteins. No. If there is same sequence, then protein should be same. Fine? Then that way I can tell that final protein will be decided by the primary structure. Fine? So this is where I have the primary structure. Even polypeptide will have the primary structure like protein. Now second one, that will be secondary structure. That will be secondary structure. Now in case of the secondary structure, what will happen is, for example, this is a polypeptide chain or primary structure of a protein. It is present like that. But when it comes to secondary structure, whatever amino acids are present here, whatever amino acids are present here, they will start interacting with each other. They will start interacting because chemistry, they are all chemicals. Amino acids are nothing but chemicals only. They are all molecules. They will start interacting with each other. They will make hydrogen bond. They will make hydrogen bonds with each other. So that's where these polypeptide will have their own pattern of arrangement. Their own pattern of arrangement. For example, when I am talking about secondary structure, one of the example for secondary structure is alpha helix. One of the example for secondary structure is alpha helix. So there are two types. So right-handed alpha helix and left-handed. On alpha helix, they can ask example for secondary structure. They have asked. Then you can write it as alpha helical structure. All of you are using pen, right? So in that we have the spring. Same way this helical structure will be there. It will be like a spring. Now right-handed means, observe me when I am making the coil. When I am talking about right-handed alpha helical structure, I will rotate my pen in a clockwise direction. I will rotate my pen in a clockwise direction. Then this is called as right-handed alpha helical structure. It's having coiled structure. Alpha helix will be having coiled structure. Okay, so that's where we have the coiled structure. Now left-handed means I will rotate my pen in an anti-clockwise direction. I will rotate my pen in an anti-clockwise direction, reverse, right? So that's where I am having right-handed and left-handed. So why they have called this one? Because if I hold my right hand, helical structure will going upward direction, right? So therefore it is called as right hand. If I hold my left hand, then helical structure is moving upward. It is moving in the upward direction. That's why it is called as left hand. That's all. Fine. So that's where I have got the right-handed and left-handed helical structure. It is the best example for alpha helical structure. Now you might be having a question, sir. We had a linear polypeptide. How come it got such a pattern? How it will be like a spring? That is because presence of hydrogen bond. Presence of hydrogen bond between the amino acids. Right? When I am talking about polypeptide chain, so there will be presence of like this. Do we agree? This is a part of peptide bond here. This is a part of peptide bond here. There will be presence of hydrogen bond. Because hydrogen linked to an electronegative element and oxygen is an electronegative element. So there will be formation of hydrogen bond. And due to this interaction, this linear polypeptide will get folded in different patterns. So that's where we have the secondary structure. Fine. Now, another example for secondary structure is beta pleated sheet. Another example for secondary structure is beta pleated sheet. Is there in your syllabus? Okay, now. So alpha helical structure, beta pleated sheet. Now pleated means like this. It's like a sheet which is present on the building top. They will put sheet, right? Cement sheet. So it will be like this pattern only, wavy type. But not exactly wavy, there will be sharp ends. So that's why they are called as pleated. So alpha and beta, that name only because alpha helical structure was found first. Therefore they kept the name it as alpha. After finding the alpha, then they later found the beta pleated sheet structure. That's why they kept the name it as beta. Nothing to do with structure. Okay. So it is helical. This is pleated. So that's where two polypeptide chain which will be making hydrogen bond. So that's where beta pleated sheet structure will be there. All of you will agree? So secondary structure is due to interaction of amino acids. Secondary structure is due to interaction of amino acids where polypeptides will attain different shapes. That is nothing but secondary structure. All of you have understanding? They have asked. Give an example for secondary structure of a protein. Then you can go for either beta pleated sheet or alpha helix, any one. It's up to you. Fine? So that's where we have the secondary structure. Now I will come to tertiary structure. Tertiary structure. Okay? So as the name itself indicates, it's a foundation. If you go back, don't write that one in exam. To make you understand, I am telling, it's a foundation. Then comes based on the type of amino acid, interaction will start. Then based on that, different secondary structure will be formed. It's like a wall. The pattern of foundation you have laid, in the same pattern wall has to be laid. Right? So that's what primary structure is going to decide whether I am going to get alpha helical structure or beta pleated sheet structure. Right? That is related to secondary structure. Now we are coming to next level. That is tertiary structure. It's like a slab. We are putting a slab. Now when I am talking about tertiary structure, now these are the structure resulted due to, listen to me carefully, tertiary structures are resulted due to interaction of an amino acid, interaction of the amino acid which are far from each other in a polypeptide. Tertiary structure is due to interaction of the amino acids which are far from each other in a polypeptide. That is very important. Fine. So that's where we are going to get the tertiary structure. That's where we are going to get the tertiary structure. Now tertiary structure can give rise to globular pattern or whatever it is. It can give rise to globular pattern. Okay, different types of tertiary structures are there. But one thing you should keep it in your mind, that tertiary structure is due to interaction of amino acids in a polypeptide, but they are far from each other. Right? They are far from each other. That's where we have the tertiary structure. Here also hydrogen bond will be there, disulfide linkage will be there, electrostatic interaction will be there. So they are going to decide the which type of structure we are going to get. What is the shape of the protein? It will be decided by the tertiary structure. Fine? So that's where we have the tertiary structure. Now I will make it very clear. In the nature, whatever proteins we have, all of them compulsorily they have primary, secondary and tertiary structure. We don't have a protein which does not have secondary and they will have primary and tertiary. No, it's impossible. Can you imagine a house, foundation and slab without wall? It's impossible. Same way, primary structure if it is there, then only secondary structure will be there. Once secondary structure is there, then only tertiary structure will come. Fine? All of you have understood? Now, another level of structure is quaternary structure. Another final level is quaternary structure. Now, my students will be having a doubt. They are not asking, they will be having a doubt, sir. Foundation ಆಯಿತು, ವಾಲ್ ಆಗಿದೆ, ಸ್ಲ್ಯಾಬ್ ಆಗಿದೆ, ಇನ್ನೇನು ಬೇಕು ಸರ್ ಮನೆಗೆ? ಇದು ಯಾವ ಲೆವೆಲ್ ಆರ್ಗನೈಸೇಷನ್ ಸರ್ ಇದು? Why quaternary structure is required? Now, we are talking about single story building. Up to tertiary structure, I am talking about single floor. If I have a duplex or triplex, or if I have an apartment, right? So that's where I have got the quaternary structure. What I mean to tell you is, we have many proteins which will be having more than one polypeptide in their structure. We have many proteins which will be having more than one polypeptide in structure. Same way, we have many proteins which will be having single polypeptide in their structure. For example, biology students, they will be knowing this one. We have one of the protein called as myoglobin, right? So which is oxygen storage protein in the muscles. Myo, M-Y-O, myo stands for muscles. Globin is due to globular structure, that means spherical structure. So that's where we have the myoglobin, right? So biology students will be knowing, and computer science students you can know now. When I am talking about myoglobin, it is nothing but a globular protein having single polypeptide, right? So Ravikant, whatever you have written is absolutely right. So before that I have to give some explanation. Fine? So that's where we have the myoglobin which will be having primary, secondary, tertiary. No quaternary structure in myoglobin. It will have primary, secondary, tertiary. Okay? But when it comes to quaternary structure, compulsion here is they should have more than one polypeptide. since myoglobin is made up of single polypeptide, they cannot show the quaternary structure. They will not have the quaternary structure. Which one? Myoglobin, because they are having single polypeptide. So therefore they will show primary, secondary and tertiary structure only. Fine. But when it comes to quaternary structure, as Ravikant has written, he has used one term, subunits. Now that subunit stands for that individual polypeptide present in a protein. Say for example, if I take hemoglobin, all of us we know it is an oxygen carrier, it is oxygen storage, it is oxygen carrier protein present in the blood, right? So that's where we have the hemoglobin. Heme stands for blood. Globin, once again, shape of the protein, globular shape. So hemoglobin is a globular protein present in the blood. Myoglobin is a globular protein present in the muscles, right? So both are involved in binding to the oxygen. Anyway, I am not going to detail, but when I am talking about hemoglobin, it is having 4 polypeptide, alpha 2, beta 2, right? So alpha 2, that means same type of polypeptide 2 copies. Beta 2, that means same type of polypeptide 2 copies. Don't get confused about alpha helix and beta. I am not talking about alpha helix and beta helix here. It is name of the polypeptide they have kept. Alpha 2 means 2 alpha types of polypeptide chain, same polypeptide. Beta 2 means 2 beta polypeptide of same type. Okay? So therefore total 4 polypeptides are present if you observe. 2 alpha, 2 beta. Total 4 polypeptides are present in hemoglobin. Therefore it can show the quaternary structure. As he has written, quaternary structure is nothing but interaction between these polypeptides. How they are going to arrange in a 3D view, how they are going to arrange, that is nothing but quaternary structure. That's what he has written, spatial arrangement, right? How they are going to arrange. For example, if imagine this is one polypeptide, this is another polypeptide. This polypeptide can have interaction like this, or they can have interaction like this, or they can have interaction like this. So whatever it is. So that's where the arrangement of these polypeptide, that is going to be quaternary structure. And whatever individual polypeptide is there, in a quaternary structure it will be called as subunits. Whatever he has written is absolutely correct. That's why they are called as subunits. Fine. So now I can tell, to simplify, quaternary structure talks about interaction of subunits. Interaction of subunits in a protein. Interaction of subunits in a protein. Whether I am clear? So all this interaction will be present in the protein. One thing is sure, a single polypeptide containing protein will have only up to tertiary structure. When we have more than one polypeptide containing protein, then they will have primary, secondary, tertiary and even quaternary structure. All of you have understood what I am telling? So that's what with respect to different organization with respect to the proteins, which is basically due to interaction of amino acids, which is basically due to interaction present between the amino acids. And please remember, except disulfide bond, all the other interactions are non-covalent interaction. Disulfide bond is the only one which is covalent, which is going to decide the structure of a protein. Okay? So that's where we have the quaternary structure. Special arrangement, no, it is spatial. Only that word you change, you will get the answer, that is fine. Spatial arrangement of the polypeptides. in a protein, then it is called as quaternary structure. That is fine. You can write subunit or polypeptide. Fine. All of you have understood? So therefore, when I am talking about proteins, they have primary, secondary, tertiary. If they are having more than one polypeptide, they will have primary, secondary, tertiary and quaternary. That is the difference between polypeptide and a protein. So what I will make it clear here is, I have a protein. Okay? So I have a protein in a solution. I have a protein in a solution. Now what I will do is, I will add some acid to that solution. I will add some acid to that solution, or I will add some base. Even in my lab sodium hydroxide ಇದೆ ಅಲ್ವಾ? So what I will do is, I will prepare sodium hydroxide solution. ಅದೇ ರೀತಿ ನಿಮ್ಮ ಲ್ಯಾಬ್ ಅಲ್ಲಿ HCl ಇದೆ ಅಲ್ವಾ? Then I will prepare HCl solution. Anyone, ಎರಡು ಒಂದೇ ಸತಿ ಅಲ್ಲ? Anyone, acid or base, any one of these two, I will add it to the protein solution. Now protein will get denatured. That's why another important term. So protein will get denatured. That's where we have the denaturation. Okay? And protein will now converted into polypeptide. Protein will get converted into polypeptide. Same way, either this one or this one, or what I will do is, I will heat the protein. I will heat the protein solution. Once again, it will undergo for denaturation. Then I am going to get the polypeptide. Got my point? So that's why it is called as denaturation process. That's why it is called as denaturation process. That means a protein having primary, secondary, tertiary and quaternary structure will get converted into a molecule which is having only primary structure. Because polypeptide, they are having amino acid sequence. Therefore primary structure is intact, but all the other structures are lost due to sudden change in the condition. What is that condition? Change in pH. These two related to change in pH. Right? So that's where change in pH. And another one is heat. Change in temperature. Okay? So that's where I am going to have the denaturation of the protein. Very beautiful example for this one is, every day we are saying curdling of milk or conversion of milk to curd. Right? That's where we have the denaturation, where milk proteins will get denatured. Due to that, we are going to have the curd. Why it is happening? Because change in the pH. When we have a milk, if you add lemon juice, or if you keep it, yes, Ravikant, muscle, okay na? So, or if you add lemon juice, a few drops of lemon juice or any acid. But anyway, any acid we cannot add because we are going to consume that one. So we will add lemon juice, or if you add old curd to that. Now what will happen? Absolutely fine, Janal, very good. There will be formation of lactic acid due to microbial metabolism. There will be formation of lactic acid. So which will change the condition in that milk. So due to that, a protein will get denatured. So that is nothing but denaturation. Very good example is curdling of milk. Curdling of milk. So that's where we have the very good example for denaturation. Important term. Right? So if someone asks you, what is denaturation? What you are going to tell? Denaturation is a process where a protein will get converted into a polypeptide, or protein will lose its secondary, tertiary or quaternary structure and it will have only primary structure. Then it is called as denaturation. All of you have understood? Whether it's clear, it's there in your syllabus. Okay, so bit important for your exam. Same way, same protein I am going to treat with protease or peptidase. I will treat with the protease or peptidase, like amylase and all we have discussed, right? Sucrase, amylase. What they used to do? They are going to cleave the glycosidic bond. Same way, protease or peptidase is going to cleave peptide bond. Yes, milk and lemon. We get paneer. Okay, paneer is in the same pattern of curd apam. Exactly how paneer will be prepared, I don't know. But that is, yes, whatever you have written is correct. Okay. So when I am talking about protein, we have primary, secondary and tertiary quaternary structure, right? So when I treat with protease or peptidase, in the name itself it is there, they are going to cleave the peptide bond present in the protein. Now you should tell me, resulting molecule, whether it should be a polypeptide. I have a protein, I have treated with these enzymes. In that case, whether I am going to get the polypeptide as the product? Anyone? Whether I am going to get the polypeptide as the product? Okay, fine. Okay, tell me whether we are going to get the polypeptide as the product. Anyone? Anyone can write. Here we have seen we are going to get the polypeptide in this case. That is called as denaturation. Whether same way here also it is denaturation where protein will get converted into polypeptide. Anyone? Okay. Okay. Cheese or what he had written there? How exactly it will be prepared, even I don't know. I am very poor at cooking. Milk to curd, I know. It's very easy. But answer for this, anyone? Now, from protein, when it is treated with protease, we are not going to have the denaturation because we are going to get the fragments of peptides. We are going to get the fragments of peptide and even some amino acid. That means I have lost primary structure also. When I am treating protein with protease and all, I have lost primary structure also. I am going to get the fragments. That is the difference between denaturation, and that is the difference between when a protein is treated with protease or peptidase. All of you have understood? Any doubt? If you have any doubt, you can ask. Otherwise, I will move to the next one. Okay? So now, last part of the proteins. That means, I am talking about different types of proteins. I am talking about the different types of proteins. Now, when I am talking about different types of protein, based on their shape, based on the shape of the protein, we can have fibrous. Yes, Ravikant. Okay. In that case, we have the classification of protein based on the shape. One is fibrous protein and another one, just now I told, globular proteins. Another one is globular proteins. So these are the different types of protein based on their shape. Okay. Now, when it comes to fibrous, in the name itself it is there. They will be having linear structure where one polypeptide or more than one polypeptide, they will be interacting with each other and they will form a fibers like a cables. It will be there, right? So it looks like a cables, but very, very small in structure. Now, the example for this type of protein is Very beautiful example is collagen. All of you know, which is one of the abundant protein present in our body. Right? That's where we have collagen. Same. Keratin, as Ravikant has written. Keratin, which is present in our nails, hairs. So that's where we have the keratin. If you burn your hair, it will give very odd smell, right? So that is due to sulfur content present in that protein. So which are those amino acids which are having sulfur? Anyone? Which are those amino acids? Yes, myosin. Yes, myosin related to muscles. Myo stands for muscles. Anyone? Which are those amino acids which will be having sulfur in that structure? That is cysteine especially, and another one is methionine. So therefore when you burn your hair, you are going to get the odd smell that is due to the sulfur. Right? So that's where we have the keratin. So all of them major function, especially these two, major function is support. Yes, Kritik, methionine, cysteine and methionine, yes. So collagen and keratin, they are majorly giving the support to the tissues. Okay, they will give integrity, they will hold the tissues intact, these two. But when it comes to myosin, important role is muscle contraction. Biology students will be knowing. Important function is muscle contraction. That's where we have some of the example for fibrous protein. Okay? That's where we have some of the example for fibrous protein. Yes, Kirtana. Cysteine, another example for sulfur containing amino acid, no doubt. Fine? So that's where we have the fibrous protein, which are linear in structure. Multiple polypeptide will interact, which will become strong now. That's what collagen and keratin will do. Right? Porcupine, that quills will be there now. Kannadadalli have mullandi. Right? So that particular needle, which will be very sharp, that is actually rich in keratin. That rigidity is due to keratin. Our nails, kachitivalva, ಅಥವಾ ಬೇರೆಯವರಿಗೆ ಬರ್ಲಿಕ್ಕೆ, so that is also due to keratin. You can imagine, right? So that's where we have the fibrous protein. ಮುಳ್ಳು ಹಂದಿ, ಹೌದಪ್ಪ, ಮುಳ್ಳು ಹಂದಿ, yes. ಹಾಗಾದ್ರೆ when it comes to globular protein, they will be having spherical structure, almost spherical structure. That's where they are called as globular proteins, spherical structure. Example, anyone? Just now I had told. Example for globular protein. Just now, 10-15 minutes back, I had told some of the example for globular protein. Anyone? Horn, yes. Very good. Insulin, but that one I didn't give example. Fine, insulin can be included here. Any other? No, primary I didn't tell. No, Janavi. I am asking about example for protein. Albumin, even this one I didn't give as the example, but albumin, which is one of the abundant protein in blood, yes, we can include here. But that one I didn't give the example. Any other? For globular protein. Yes, Kirtana, very good. You saved me. That is hemoglobin and myoglobin can also be included. Okay? So these are some of the example. Insulin, albumin, absolutely fine. They are also example only. But what I told was hemoglobin and myoglobin. In the name itself it is there. Globin, globular. So that's where they are the example for globular proteins. Okay? Any doubts? So by this proteins, this chapter is done. In that way, I will move to the next one, a brief introduction. I will give first. We will discuss briefly first about the nucleic acids. We are going to discuss about the nucleic acids, another important biomolecules. Okay, so another 5 minutes. Okay, now, so that's where we have the nucleic acids. Now, in the name itself it is there, already I have told. Nucleic stands for nucleus. Acid stands for negative charge. That is due to acidic component present in them. Therefore, they are called as nucleic acids. Fine. So, very important example here is, all of you know, that is DNA and RNA. These are the two important nucleic acids present in our cells. Right? So, one is DNA and another one is RNA. So, DNA is nothing but deoxyribonucleic acids. Deoxyribonucleic acid. ಅದೇ ರೀತಿ RNA is ribonucleic acids. Now, I will make it clear for your exam, no structures is required, but they will ask some question which I will tell. Structure is not required. I will write the structure to make you understand, that's all. When I am talking about deoxyribo, that means I am dealing with the ribose sugar, which is a aldopentose. It may be helpful for your competitive exams. I am talking about ribose sugar, which is nothing but aldopentose. What do you mean by aldopentose? An aldehyde containing or 5-carbon sugar, or 5-carbon sugar containing aldehyde as its functional group. So that's what ribo talks about. Fine. So now, if I write the ribo cyclic structure like glucopyranose we have, same way ribose also can have the cyclic structure. That's what I am writing here. So I have OH, OH, OH and CH2OH. So whatever I have written is the cyclic structure of ribose sugar. Once again I will tell, no one will ask you about write the structure of nucleic acid. No, it is not there in your syllabus. But to make you understand, I am writing, because in textbook they have given the structure. But question will not be asked. Okay? So that's where we have the ribose sugar. That is fine. Ribose. But here it is written as deoxyribose. Here it is written as deoxy. Deoxy means no oxygen. Right? So that absence of oxygen will be with respect to, I will write separate only. That absence of oxygen will be OH, 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 CH2OH. Absence of oxygen will be here. Okay? So that's where we have the H, H, okay. All the other hydrogen also I will write to avoid the confusion. So that's where I have the ribose, and that's where I have the deoxyribose. Now, why we have to call it as deoxy? Because there is no oxygen. There is no oxygen here. Therefore, it is called as deoxyribose. So, deoxyribose. This is the sugar which is present in DNA. So, this is the sugar which is present in the RNA. This is present here and this is present here. So, deoxyribose is present here, ribose is present over here. All of you have understood what is that difference between these two? All of you have understood, right? Any doubts? So that's where we have the ribose, deoxyribose. And now another point. If you want to number 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5 carbon. That means here at second carbon it is not there. So therefore we can call it as 2-deoxyribose. 2-deoxyribose. All of you have understood? Any doubts up to here? Any doubt ideyappa? So that's where we have this one with respect to RNA and DNA. Now along with that, we have to discuss about nitrogenous base. Along with that, we have to discuss about nitrogenous base. Now when I am talking about nitrogenous base, in the name itself it is there. They are called as a base due to the presence of nitrogen. Okay? Now, we have two types in this nitrogenous base. One as purine and another one as pyrimidine. Both are heterocyclic ring molecules. Both are heterocyclic ring molecules. Say for example, once again, structure is not required for your paper. Now when I am talking about purine, it is having double ring structure. It is having double ring structure. This is where I have the purine. If I take pyrimidine, half of this ring, that means this part, that is nothing but pyrimidine. Right? So that's where we have the nitrogen in the ring. That's where we have the nitrogen in the ring. So we can have the double bond to have the avoid the confusion. Now all this nitrogen, they have the lone pair of electron. So therefore they can act as a Lewis base. So therefore it is called as nitrogenous base. Therefore they are called as nitrogenous base due to the presence of lone pair of electron on this nitrogen. Right? So two types of nitrogenous bases are there, purine and pyrimidine. Now some modification, I am not going to detail. When it comes to purine, the ring size is large, name is short. That's how you can remember. Ring size is more, but name is small. Example will be adenine and guanine. They differ with respect to substitution for this ring structure. Okay, one is adenine and one is guanine. Now in the case of pyrimidine, structure is small but name is large. Yes, what happened? Getting confused? Huh? So once again I am telling, structure is not required. Okay? So no need to worry about the structure. But you should remember the names. Okay? So don't worry, structure no one will ask. If you are not understanding anything, let me know. Okay? So now when it comes to pyrimidine, we have cytosine, thymine and uracil. Okay? So remember the name. So when it comes to purine as the nitrogenous base, we have adenine and guanine. When it comes to pyrimidine as the nitrogenous base, we have cytosine, thymine and uracil. Anyway, I will stop here. So while coming tomorrow, you should be thorough with this nitrogenous base. You should remember, when I will ask which are those pyrimidine base, you should give answer quickly. Same way, if I ask purine, give an example, you should give very fast. Fine? So in the same way, ribose and deoxyribose. So tomorrow once again we will continue. Any doubts? Okay? So once again I will tell structures, whatever I have written here, no need to worry. When it comes to biomolecules, you have to remember or you should practice structure related to disaccharide. Okay? So now that is the only structure which is required. Then deuterionic structure, amino acid. Okay now? Fine. Thank you. Thank you. Take care.